Hi everyone, I am Chandu and then I am going to present about the topic titled as Design and an Implementation of Security Operating System based on Trusted Computing. It was a proposed idea developed by Zia Wei, Zian Zun Chi and Zin Pu Wang, and I am going to discuss about the topics such as overview of the trusted computing BLP model, design of IBLP's security model, overall design of the security operating system based on trusted computing, and then following the trusted identification and access controls, and next integrity measurement and security audit, and ending with experiment performance and conclusion. Now I'm going to present about the overview of trusted computing. Trusted computing is also known as confidential computing. It is a technology developed by Trusted Computing Group. The main idea of the trusted computing is to give the hardware manufacturers control over what software does and does not run on a system by refusing to run on unsigned softwares. The behavior of the trusted computing will be enforced by computer hardware and then software applications, and then key concepts in the trusted computing are being broadly divided into four types. First one is endorsement key, and the second one is memory containing. The third one is seal storage, and the fourth one is remote attestation. The first one, endorsement key. It is a 2048-bit RSA public and private key. It is a combination of both public and private key, which was randomly generated on the chip at the manufacturing of the endorsement key, and that cannot be changed for further process. The main theme of endorsement key is for the security transaction purposes, and the trusted platform module is required to able to sign a random number at the time of endorsement key for security purposes. In memory containing, it extends the common memory protection techniques to provide the confidential data from being attacked by malicious attacks. In seal storage, the seal storage protects the private information by binding it with either hardware data or with software data in order to protect the confidential matter. This means that the data can be released only to a particular combination of a software or hardware. Seal storage can be used for the DRM enforcing for further process. In remote attestation, it works by having the hardware generates a certificate stating what software is being currently running in particular system. The computer can then present this certificate to a remote party to show that unaltered software is being executing, whether it may be the good one to execute in the system or not can be defined from further conclusion. And numerous remote attestation schemes have been released, for example RISCV and then ARM. And the trusted computing platform system structure is being showing here. It has been divided into three layers. The first one is TCP application, the second one is TCP operating system, and the third one, which is the core part, that contains TPM, CRTM, CPU, and then other chips. Coming into the TPM, the trusted platform module, it is the core hardware level security framework which generates the encryption key and also for the decryption, and then it also secondarily protects the BIOS and the OS from malicious attacks. The CRTM, which can be defined as core root trust module, it initializes the entire system and authenticates the BIOS of the system. The TCPA OS, it supports the hardware modules and applications. On the TCPA, we have a TCPA application which runs on basis of TCP operating system and TPM and CRTM. The compatibility of TCPA is an opener system which permits more widespread trusted computing realization based on it. The operating system offers security link between the hardware, trusted computing, and then applications of the system. The first BLP model. It is a security model which was designed by the David Bell and Leonard LaPadula for the military purposes at the initial stage. In BLP, there are mainly four access attributes. We name them as E access, R access, A access, and W access. The E access, we generally define it as an execute the queries with neither observe or no alter. And then R access is generally known for observation of the query with no alter. And then A access is defined as alter the query with no observation, and W access, it is defined as execute query with both observation and then alter. On the other hand, BLP has a triplet known as B of SOA, which means that in BLP, S denotes the set of objects, O denotes the set of objects, S denotes the set of subjects, and then A denotes the access attribute. In BLP, we mainly focus on two security properties. One is simple security and other one is star property. In the simple security property, it is satisfied if SOX belongs to B, where S of R tends to SE of S greater than or equal to SE of O. It means that every observation access triplet, which is B of SOR in the current access set, has the property that the security level of subject dominates the security level of object. It means if the security level of subject is greater than the security level of object, then the B of SOR is been satisfied. In the star property, it is satisfied if for all SO of X belongs to B of SO of A tends to SE of S less than or equal to SE of O. And it means that every alteration access triplet B of SO of A has the property that the security level of object dominates the security level of subject. And the issues in Bell LaPadula model are obtaining two largest access privileges is being a issue where all the access privilege which has been opted doesn't follow the set of principles. And then BLP model mainly focus on the confidentiality, not on the integrity of the data. To overcome these issues, there has been designed a IBPL security model, which is improvement of Bell LaPadula model. Here we have security attribute and then security domain. In security attribute, we will make an consideration about the confidentiality integrity of every subject and object. Every subject and object has an security attribute. It has an three components: confidential level, integrity level, and then access category. In security domain, the security domain of the subject can be classified as a common subject and trusted computing subject. Moreover, the axiom of IBPL model. Here we have two properties, which one is simple security property and then star property. In simple security property, from given formulas, we can say that from the first two formulas, it has been defined that the common subject can neither observe or not execute the information of the object on the higher confidential level. It means if there is a common data that has been sharing upon the object on higher confidential, it can be neither observed or can be neither executed. And then from the third or fourth form, it can be derived as the trusted subject on the lower confidential level can neither observe nor execute the information of the object on the higher confidential level, and unrelated information but can observe and then execute. The unrelated information can be observed and execute but not the related ones on the lower confidential level. Here in star property of the IBPL model, from given set of formulas, we can say that the common subject can only alter information of the object on the same confidential and integrity level and cannot leak the information of further unrelated objects. In 7 and 8 formulas, we can derive that the trusted subject on the lower integrity level cannot alter the information of object on the higher integrity level, but can alter information of object on the lower integrity lower confidentiality level. From the two properties IBPL, it makes an integrated consideration about the confidential and integrity of every subject and object. This was the case where the BPL has been lagged and then IBPL has been introduced. Then it classifies the domain of the subject and access category of every subject and object. Finally, the IBPL established the access control principles on them to achieve security requirement of the trusted computing. Coming into the overall design of the security operating system, in the overall design, the security operating system mainly responsible for certificating the processes and then distributing the applications. In the overall design of security operating system, we can look into the figure, which has been broadly classified into three layers. The first one is the application, the second one is security kernel, and the third one is the hardware. In the application, we have a trusted software where the login programs takes place, and the privileged user login based on the credentials, and then common users can share the resources of the trusted computing. In the security kernel, we generally look into the system calls, and then access control methods, and then security audit, and then trusted identification takes place. Where in the hardware, it contains the trusted hardware of a specific computer of the system. Looking into the access controls, first one, the trusted identification and the access control. The trusted identification is used to ensure that the true identity of each user makes a name of the each user. For example, if the user is 100% a genuine one, or he is the trusted one, he or she makes an username with unique identifier in order to use the resources of trusted computing. Some processes that exceeds access control mechanism need to be privileged process, and the trusted identification need to identify which process is a privileged process. And coming into the access control methods, we have three access control methods. The first one is privileged access control. The privileged access control based on IBLP ensures that the trusted processes only gets the security privilege that meets the requirement of the task. In the discretionary access control, the discretionary access control, which is commonly known as DAC, uses the control list. It contains the specific control list of ACL defined by the user to implement the access control of a resources. A typical ACL mechanism shows as follows. It contains the type ID following with the permission, in which type means the processor type, ID is the user ID, and then permission means access privileges of the user. And the third access control method we have here is mandatory access control. The corresponding security level is assigned to each process, document, and IPC set that contains message queue, signal set, and then shared storage by the system. When a process accesses an object of MAC mechanism based on IBPL, that compares the security level between the process and the object to determine whether the process can access the specific objects which is required by the user. And then integrity measurement and then security audit. In integrity measurement, you can see the following diagram where it contains the integrity validation mechanism, integrity challenge mechanism, and measurement mechanism. And the bottom of it, it contains the trusted BIOS measurements. And in TPM, we have platform configuration registers. Here, the measurement mechanism, which is the main core part that measures the runtime environment, and the integrity challenge mechanism allows the authorization to retrieve the measurement list. The integrity validation mechanism validates the whether measurement list is non-tampered and entries of runtime components described thoroughly or not. Here, the integrity validation mechanism, first it generates the integrity challenge, and then integrity challenge mechanism, which gets those integrity challenges in following, it derives the code regarding to the TPM. And then here TPM, based upon the platform configuration register and with the trusted BIOS and then measurements, it reports the codes and send back to the integrity challenge mechanism. After getting it, the measurement mechanism generates the measurement list which are to be measured in terms of files to the integrity challenge mechanism. After getting the measurement list, the integrity challenge mechanism in turn generates the integrity responses from the codes it has been derived to the integrity validation mechanism. Here, the integrity validation mechanism, the main part of this is to validate the responses which has been retrieved from the integrity challenge. And the security audit of the trusted computing platform is the main thing which mainly audits any security related events. In this case, the security audit here focused on the system events. In order to every security audit related system is audited or not. The security audit against the only interface is by user applications and the system calls. I mean, tracking the user applications and the system calls. We need to implement them. At the same time, for some system privileged instructions, which usually use system call and may have an impact on the system security, considering the audit against every system call used by the privileged instruction will make audit too complex, too difficult to understand for auditor to judge the situation being used. So we add our audit against the privileged instructions. And the experiment and performance on the basis of known vulnerabilities in Linux, as the proposed system is been focusing upon the Linux OS. Here the persons who has been implemented this idea carried out the penetrating test for security operating system. Some of the typical experiment results has been shown on the table 1. On the table 1, they have mentioned the attack type, IP cheating, buffer overflow, denial of service, and rootkit. These are all the types of attacks. And then rate of detection, by implementing the trusted computing platform of the subject, they can overcome the 80% of the IP cheating. I mean, they have been successful to the 80%, where finding the what type of attack it is and how to implement from them. In the case of IP cheating, it is 80%. In the case of buffer flow, it is 85%. In the case of denial of service, it is 87, and in the case of rootkit attack type, it is 95, which is significant. And the examine of decline of performance of the system through the execution of efficiency of IPC process and the system call of the file system in common Linux is been shown in the table 2. In the table 2, the test project, test IPC, test fork, and test FS has been displayed, where the decline rate has been seen. In the test of IPC, it is 8%, where after the attacks, these are the results after the attacks, where the test IPC has been significantly dropped to the 8%, which is done by implementing the trusted computing platform to the operating system and then hardware applications. In the test fork, it is 10%, and in test FS, it is 10%. Therefore, I want to conclude with an statement such as, in conclusion, the security of operating system is the key for the implementation of a trusted computing platform, and the trusted computing based model IBLP is being improving traditionally by overcoming the BLP model. The future work of presented IBLP model can be achieved by improving the optimization algorithms, and the results make more optimized balance between the performance and the availability of the security operations systems. Thank you.